All right, our last example in Chapter 12, this is 12.5, example number 4. We're going to do an application problem using our logarithmic derivative rules. It says here, based on projections from Kelley Blue Book, the resale value of a 2014 Toyota 4Runner SR5 can be approximated by the following function. So F is the resale value, and T is the number of years since 2014. It asks us to find and interpret what f of 4 is and what f prime of 4 is. So remember, f is the resale value of this Toyota 4Runner. T is the number of years since 2014. So when we say t equals 4, or f of 4, that really means we're talking about 4 years since 2014, or we're really talking about 2018, right? If we plug in a 4 into my original function, and I'm going to use my calculator. You should all have a log button. Make sure you pause the video at this point and you know how to enter this in your calculator. I entered it in just like it was with all these parentheses, and I ended up getting approximately 19,776. So pause the video, make sure you can enter it in your calculator in case there's a homework question or a test question, you can get the right answer. And now let's go ahead and interpret what this means. Well, remember that t equals 4 is really 4 years after 2014. So you can say after 4 years, or you can say in 2018. And remember, f is really the vehicle's resale value. So 4 years after 2014, the vehicle's resale value is approximately $19,776. That's when I plug in 4 to my original function. The second part of the question, though, asks us to figure out what f prime of 4 is and then make an interpretation. Well, we know that the derivative of f is really just the rate of change. And so when we find the derivative of f, we're really talking about the rate and change of my resale value. Is my resale value going up, or is my resale value going down? We're finding the rate of change. Let's go ahead and find the derivative of f. I know that the derivative of 30,781, the derivative of any number, is just 0, right? And then I notice that I have this negative 24,270 in front. It's a coefficient. It's just a number, so I should be able to bring that number out in front and leave it a negative 24,277. And then the rest of my problem, I can find the derivative of. So this is a log problem with a whole bunch of stuff inside. So what rule was that? A log with a whole bunch of stuff inside. It looks like that's rule number 4b, right? Where we can do 1 over the natural log of the base times the derivative of the inside over the original inside. So let's do that. Here we go. I have my coefficient, my negative 24,270. I have 1 over the natural log of the base. And remember, when there is no base written, it's assumed to be a 10. So 1 over the natural log of 10 times the derivative of the inside, which is 0.46, over the original inside, which is 0.46t plus 1. So this is my derivative of t, or my rate of change, my change in my resale value at any time. Now let's figure out what it is when t equals 4, or in 2018. I can plug in a 4. And again, you should be pausing your video. You should be plugging this into your calculator so that you know how to get the correct answer, making sure you know where your log button is and your natural log button so that you can calculate all of these answers correctly. All right, I ended up getting negative 1,708. So what does that mean? Well, when does this happen? What is happening? And what is our answer with correct units? Well, this is happening in 2008, or 4 years after 2014. The resale value is decreasing because of that negative, and it's decreasing by $1,708 per year at that moment. My car is losing value, losing over $1,700 of value per year in 2018. So I need to make sure that I sell this bad boy so I don't continue to lose value, right? Now you notice that I didn't say decreasing and then put a negative in my number. We normally take out the negative and use the word decreasing. So it decreases by 1,708. We don't say it decreases by a negative 1,708. So be careful with that. And then make sure that you use the correct wording where you're saying the resale value decreases, okay? All right, so make sure you know how to apply all of those logarithmic rules and exponential rules. Make sure you take a look at the formula sheet that's posted in Canvas so you know what's going to be provided to you and what's not going to be provided to you. You should also have some sort of a derivative rules worksheet, bell work, whatever I called it, that has all of the different rules that you need to memorize. So it looks like there's 2, 4, 6, 8, 9 different rules that you should be memorizing for your homework and your exams. So hopefully you've practiced so much that you won't actually have to memorize them, that they just become sort of natural as you're going through and taking derivatives, because derivatives are huge. We're going to be doing derivatives for the rest of the time in this class. Actually, the first step on every single problem in the whole next chapter is to take the derivative, and then we're going to do even more with it. So it's really important that you have this good foundation of taking derivatives so that we can do more with it later on, okay? So make sure you know the rules, make sure you practice, 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 make sure you're working on those reviews in my math lab as many times as you need to. And remember, I suggested to possibly do the review out of order. So you're not just focused on product rule, and you're not just focused on quotient rule, and you're not just focused on chain rule, but if you do them out of order, you'll kind of test yourself so that you know what rule to use when the equations are all out of order, right? All right, let me know if you need anything, and take care. Hope you're doing good.